Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be air. In this topic, we'll be talking about the atmosphere and also a little bit on the environment and some pollutants. So basically what the air is made up of, it will be this. This is the proportion of the major constituents of the air. Nitrogen about 78, oxygen about 20, 21, carbon dioxide 0.03%, and the rest are pretty negligible. So questions we always like to ask: in a jar, if you put a candle inside, completely burn out the oxygen, it should consume 20% of the air in the jar. This you need to know. So how do people quantify all this? Is by fractional distillation of air. They cool it into a liquid and make it undergo fractional distillation. So that's pretty simple. So next we go on to pollution. The main pollutants will be carbon monoxide. Carbon monoxide is a gas that is produced when in the process of incomplete combustion. Each carbon atom does not have enough oxygen to produce carbon dioxide. It didn't receive two oxygen atoms. Instead it only receives one. What this does is it permanently binds to hemoglobin in the blood to form carboxyhemoglobin, students' favorite word. As a result, this hemoglobin molecule is not able to carry oxygen. This causes these array of symptoms and even death. If it was oxygen, the originally intended passenger, it only binds hemoglobin temporarily and goes to the destination and it dissociates with hemoglobin. Carbon monoxide binds permanently. Next, it will be oxides of nitrogen, either nitrogen monoxide or nitrogen dioxide. This is formed by extreme heat in factories or in car engines. The oxygen component in the air and the nitrogen component in the air will come together to form these two oxides. In addition, it's also formed by lightning. Oxides of nitrogen also forms acid rain that destroys the environment. Next will be sulfur dioxide. Sulfur dioxide is formed by combustion of fossil fuels as well as volcanic eruptions. And because sulfur dioxide and oxides of nitrogen, they are non-metal oxides, recall earlier topic, they are acidic oxides. They form acids with water in the air and turn into acid rain to damage the environment. Next will be things like unburnt hydrocarbons from car exhaust, methane from decaying metal or produced by animal livestock. And methane is a greenhouse gas. It traps a lot of heat in the atmosphere. So there's a lot of mention on acid rain. So basically it's all these non-metal oxides mentioned earlier that they combine with water, sometimes oxygen as well, to produce an acid, and they rain down onto the environment and cause a large variety of effects, damaging buildings, metals, affecting the environment, in the aquatic life, plants. So it's always good to understand all this and think of ways to reduce the effects of all the pollutants. So petrol, fossil fuels, a lot of burning is involved. One way is to think of policies to reduce the use of vehicles, turn to other cleaner fuels. When clean fuels are mentioned, it means that the products that are being produced are not harmful to the environment. Things like hydrogen fuel or electric cars. So next we talk about ozone. Ozone is an O3 molecule, so oxygen atom, and an oxygen molecule will give you ozone. It's good at the upper layer of atmosphere, but not so good at the sea level where we are all situated at. It's actually considered a pollutant at low levels, but at the high levels it's a shield that prevents excessive ultraviolet rays from entering the earth. So this molecule, CFC, chlorofluorocarbons, used by propellants, aerosols, refrigerators, air conditioners in the past would contain these CFCs, and they decompose in sunlight to form chlorine atoms, which these chlorine atoms will go on to react with ozone molecule, thereby creating gaps and holes, breaking up the shield that we have in the upper atmosphere. Therefore, the harmful ultraviolet rays from the sun is able to enter the earth. So since then, many countries have already banned the use of CFCs. So talking about the reduction of air pollution, other than policies on fuel types and the technological advancement for cars to be more environmentally friendly, A catalytic converter is also used to help reduce the amount of harmful emissions from vehicles. This works by combining the oxides of nitrogen with the carbon monoxide to form nitrogen and carbon dioxide, which is more friendly to the environment. Another way is for flue gas desulfurisation. Flue gas is the waste gases formed by burning fossil fuels. This is done by removing the sulfur dioxide from the waste gases, the flue gas, by using calcium carbonate in this equation. Calcium oxide also works as well through this equation. Okay, so next we will be going through the carbon cycle. The carbon cycle is covered in the earlier video in the biology playlist, but this will be covered in this video in the more chemistry perspective. So processes like combustion, respiration, and photosynthesis will be required briefly. So what is respiration? Is the burning of food to provide energy in the organic systems. So using of oxygen, food, typically sugar, with oxygen to produce carbon dioxide, water, and energy. So biology students are very familiar with this. So just remember, basically the commonly asked sugar in this level will be a C6 sugar. It is hexagonal in shape, that's why it's C6. And combustion of fuels are basically adding oxygen to hydrocarbons. So if you add oxygen to carbon, it becomes carbon dioxide. If you add oxygen to hydrogen, it becomes water. So it's pretty straightforward, and you balance out everything. Incomplete combustion will look like that. So there's a lot of these two processes will give out carbon into the atmosphere in the form of carbon dioxide, monoxide, and how is it being removed from the atmosphere is by photosynthesis. The plants will take in the carbon and mash them together with water to form sugar, which is this C6 molecule again, called glucose. Also the food example known in the front, in the earlier example. So photosynthesis is basically reversing respiration. So why do we study this is to learn to manage the greenhouse gases. Carbon dioxide is a greenhouse gas. Too much of it will cause a lot of heat being trapped inside the atmosphere, causing global warming, which leads to further downstream events like melting of ice caps and raising of sea levels. So it's like the greenhouse, the glass of the greenhouse that protects the plants and keeps it in a certain temperature. Other gases like methane, nitrous oxide are also very powerful greenhouse gases. They trap a lot of heat. And I have some little annex tips for this topic. Will be things like talking about air density. So you calculate air density by having these information. And because density is talking about the mass per unit volume, you put the molar mass on top and molar volume below, and you equate them. And there's also a lot of mention on overall equations. So perhaps questions would like to give you about maybe 2 equations, and you need to write an overall one for them. So this is one example. First, of course, you have to merge these two together. You take the different one at the left-hand side and the different ones from the right-hand side, and you force them together. Any similar ones you see within these 2 equations can be cancelled away. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!